David.
I'm Abdur.
I'm Jesse.
I'm Digny.
And our project, our final project, we did a security gate. Here's our table of contents, what we're going to be discussing and what's going to be involved in our presentation. The description of our project is we were inspired by the automatic security gate, and with all the sensor and materials that we use, and what each device did, and so also we connected it through a parallax propeller, and devices that we used for our project was a ping sensor, an RFID, a PIR motion sensor, and a joystick, and it was all connected to two servo motors. My part of this project was a ping sensor. What a ping sensor does is it uses a round trip echo time of ultrasonic sound in order to calculate the distance. Also, it requires 3 pins, which is the 5-volt ground, and pin 15, which was connected to a 2K ohm resistor. What happens is that the propeller sends a signal to the sensor to send out a high-pitched sonar pulse, which we cannot hear by our human ears. Also, the internal timer starts by measuring the time between the sensor, sending a sound signal, and the signal bounces back from the object that we are measuring. Also, the sensor does a simple conversion between the speed of sound in the air and the time taken for the signal to return. Here's a video of the ping sensor. And as you can see, when we started off with the RFID that Abdur will be explaining later, there you can notice that the ping sensor senses an object there. And with the LED green light there, it represents the system being activated. And as you can see that without the ping sensor not being able to detect something there, that the system won't be activated unless there's an object there. And you can tell that with the RFID, when we were scanning it through, that the system wasn't activated. So, yep, and then with the RFID, with the correct key being there, it opens the gate. And also, it's mostly used to measure distance. It could also be used to measure organ degradation, axil length, and muscle tissue thickness. It records time data and converts it into distant data. And with the code that we used there, we used the ping library. Basically with the ping sensor, it takes in the value, and the ping library converts it out. And with the print statement there, it tells us the distance, and there's a slight delay.
Now my part was the RFID sensor. RFID stands for radio frequency identification. Anytime you want to gain access to a secure building or even a security gate, like in real life outside in parking lots, a lot of the times you'll have either a PIN code or you'll have an RFID scan. I found that really interesting, so I wanted to incorporate that into our project. So this sensor basically has 4 pins, 5-volt and ground, and then pin 1 is connected to a 2.2 k ohm resistor, and pin 2 is connected. And then the way it works is it sends a signal that there's a coil on the RFID reader, and then there's a chip inside our key tags. And that needs to be in communication in order for the sensor to work properly. Here's a video of how the sensor actually works. So this is the wrong key being placed, and nothing happens. And this is the correct key. It opens the gate of the servo. So we took an approach where we modified the code so that we could actually get it to identify a correct key, and then arm the system basically, or open the gate and if a wrong key was submitted, the system would basically deactivate. Nothing would happen. So if you put a wrong key in front of the sensor, as you'll see later on in the video, it won't activate the arm, the light won't work either. The light will work as long as the ping sensor is sensing, but the RFID is used for the first servo motor.
Oh, the next, we use DIR motion sensor for in order to detect the motion when the car move out, and detect to the sensor and open the gate, and the car go out. With the code, the basic. And the video, so that, right. With the code here.
So is that with the correct RFID also, or was it just the proximity detection?
It's just a proximity
Well,
detection.
for this one, it was just a proximity when we tested it individually, but later it'll be with the RFID.
Cool, thanks.
So, I worked on the joystick. Basically, we used the joystick in this project as an override in case, for whatever system, for whatever situation, the automated systems aren't working. The joystick, we can use that to open and close the gates. It uses the A/D analog to digital pins on the propeller board. The joystick basically has two potentiometers inside built into it. One's for up and down, the other's for left and right. Depending on the voltage supplied to the potentiometers is what you'll see when it's displayed. Here we have video. So we have, in this case it's upside down, but that would be up and down. That's for the entrance gate. When you move the joystick up, the gate opens, and let it go, it closes. The left and right was set for the exit gate. When we move it to the right, the gate opens and let it go, it closes. Here we see we use the ADC DC prop AB.H library, using the ADC underscore volts to check the pins. Then we just used a little bit of math to manipulate what it's reading to make it from -100 to 100 as opposed to 0 to 5. That just gives us a little room with the if statements so that we can use the if statements to move the servo motors. So here's the video demonstration of the entire project working as a whole. You see the car's going to pull up. The whole system won't work unless the car pulls up first. So once the car pulls up, ping sensor activates, the green LED turns on. First we're going to try the bad key, nothing happens. Then we use the good one, gate opens, car goes through, then the gate closes. Then we're going to take the car, take it to the other side, the exit gate. Once it runs past the motion sensor, it opens, and the gate closes. So then here we see the joystick, that's the override, in case something isn't working. Move it up, the entrance gate opens, let it go, closes. Then for the exit gate, we move it to the right, it opens, then it closes. So we did have some problems. I mean, one of the major problems we had was with the motion sensor. It was very sensitive. Any movement we made around it would automatically open the exit gate, open and close it. So we did try to face it towards the wall, somewhere where people weren't going to be walking by when we were testing it. First we thought something was wrong, but when we looked at the terminal, we kept on seeing the motion sensor kept on activating. Batteries, that's how we're moving the servos. First set of batteries we used were a little low. batteries died. We thought something was wrong. We found out it was just the batteries being low. And we did have a small delay sometimes when the second servo is operating, when we try to then operate the ping sensor. There was a small delay. That's probably due to the fact that